Hello, I thought it was time to do another video on ESP32 and Rust. Last time we did LEDs with pulse width modulation, and I want to continue on that for this one. It won't be super complicated. What I want to do now is control a small servo with PWM. It's similar to using LEDs, but there are some little quirks that might catch you off guard. So yeah, let's get started. So first, let's go here. Where we left off, we had our LEDs. We used the timer, and we used the LED timer driver, and we made 3 channels that control the color of the light, and we controlled all that with HTTP endpoint, which we registered here. So for a servo, we are gonna do something very similar, but servos run on quite different kind of frequencies. As you can see, the LED is now at 1000 Hertz, which is a default. I think in many cases the LEDs don't care that much about exact frequency. I'm not sure about that actually. But servos definitely do care, and it needs to be quite a bit lower. And right now I have a really small servo. Let me show you. This is like a mini server that you typically use for like model airplanes or something like that. Super light. It's a sort of SG90 type. It's probably some knockoff, so I'm not exactly sure if it's really in spec. I put on a popsicle stick so you can see what's happening. But I'll get to the hardware in a bit. So since we are here, let's start with first of all setting up a new timer. So let's call it let servo timer, and we'll take that from peripherals. Let's see as well, and let's take timer 1. So we have to take a different one because it's a different frequency. The other 3 channels could share a single timer, but in this case we cannot. So let's create a timer driver. Driver, that is let's see, timer driver, and that's new, I suppose. We use the servo timer for that, and we need a configuration, and that's a timer config object. It's very similar, as you can see up here. So we need a timer config new, and then we need to set the frequency, and the frequency should be 50 Hertz because that's basically in the specs of this servo. Most are, I think. I need to borrow that, and also I will need to set the resolution. That is with here, resolution, and we need to say resolution. Let's see this one. And we need 14 bits. That's the max we can give. And you do need some resolution, otherwise it gets really imprecise. So let's see. That seemed to be happy. We'll need to unwrap it, of course. Alrighty, so now we have a timer driver. Next thing we do is we're gonna create another Let's See driver, pretty much the same as we're doing now. Let's do Let's See driver. Oh. and again we will need to provide a channel. So we used channel 0, channel 1 and channel 2 already, so now we need to use another channel. So let's call it peripherals, let's see, channel 3. We will use the servo driver, of course, and I connected it to pin 2. GPIO, no, pins GPIO 2. Driver, that is not correct. Alrighty, let's make it into the variable, and straight away into arc new text new, and we put all this in here. And probably, yeah, we still need to unwrap that. So, I always push the button to show the types. I don't really like them being there constantly. You can switch it on or off in VS Code, but I like to see if it's actually what I think it is. And now we have arc mutex of the thing, so that should be pretty much this part of the setup. So as you can see in the resolution, we set 14 bits. So that means that there are maximum 2 to the power of 14 minus 1. That's the max duty cycle. So that's the whole range. I didn't really explain much last time. So in the pulse width modulation, you have a pulse with a certain frequency, which is high and which is low at that frequency, but the amount, the kind of the percentage of being on, being high versus low, that's basically where we steer the servo. And as we are using 14 bits, the max value is 16.328, 27. I don't know. It's something like that. I don't know it by heart, but it's something like that. But we don't really need to calculate it. We can just retrieve it from the servo driver, I think. So we can say max duty is servo driver dot is it the servo driver? No, it's the servo itself, I guess. Oh yeah, of course. I need to lock and unwrap and get max duty. So now we have the max duty, which is that same value, but it is important because we need to use that to scale our values. Okay, now let's do the HTTP part. So this thing, the server, you can add a handler and it will return itself. So you can basically keep going adding handlers. So here I can do a function handler again. Let's call this one /servo, and we'll do a post again. And then we need to define that function. Yeah, it's pretty much the same deal. So I'm now typing just the same thing that's in the last one. Add the request here. And we end up at some point by saying okay. So now we have another endpoint, and we need to unwrap it again, otherwise it keeps complaining. So now we need to do pretty much the same things as we did before. So we need to have a buffer. We don't really need. Let's take the same. It's good enough. I guess this servo has only 180 degrees, so I think 3 digits should do it. But yeah, 6 is fine. So we can do request dot read into the buffer, and then let's do let bytes read. Probably I need to add a mutable borrow here, so that works, and we can unwrap it. So here we end up with a number. Let us parse that thing into a string. So let's say angle string is from UTF-8 of buffer, but only the bytes we have read, so 0 dot bytes read. Probably borrow. What's wrong here? Buffer. Okay, now we have angle string. Let's parse that into a number. Let's make it U32, I guess. Let angle is call it U32 is the angle string dot parse. I want to let me check. What is this? This is this needs unwrapping. Of course, so much unwrapping. And then we can do parse, and then it should infer that it needs to be U if I unwrap, of course. There we go. So now we have an angle. So now we need to set it. One thing we need to do first is so what it's gonna look like. We're gonna take that that servo and we're gonna lock it, and then we are going to unwrap, of course, and then we're gonna say set duty, and then we give it some number. So this is kind of what we want to do, and unwrap it, of course, otherwise it complains. So this is what we want to do, but right now that will be angle in degrees between 0 and 180, I suppose, because that's what that servo can do. But that's not really meaningful for the microcontroller, because as we said before, it's a duty cycle of 14 bits, so it has the 16,000 something max value, and also there is the specs of the servo, and the servo indicates that to be at, let's say, 0, so at one all the way to one side, it is 0.5. What happened? 0.5 milliseconds. Now, first of all, the frequency is 50 Hertz. There's also a spec of the servo. Might be different, but 50 Hertz is pretty common. So 50 Hertz means that one pulse is 1000 millis divided by 50, so that's 20 milliseconds. So the minimum amount of the high pulse, the high part of the pulse is a half, and the max is 2.5, so 2.5 millis. So we need to map this one basically to 0 and this one to 180, right? So then we kind of map what we intend to do, and we use for that max duty. So let's create a function for that. Interpolate or something like that. That takes some things and that returns U32. So what does it need? It needs several things. It needs the angle we want, of course. So let's call that a U32 as well. And we need to have like a min and max value. So for that we need to, let's leave this for a moment. So we need to recalculate those timings. So if we take the max duty and we have said like it needs to be, where is the, so we're starting for here. So this is a half a millisecond out of a 20 millisecond pulse. So that is basically 1/40th of a pulse, right? So we need to map that. It's basically 1/40th. So let's say let min is basically we can say max duty divided by 40. So for that I think I think that should work. And let the max, so then we are talking about 2.5. So 2.5 is out of 20 is 1/8. Let's see if that works. So max is max duty divided by 8. And if we interpolate, we can put them in here. It doesn't really. No, let's not do that. Let's keep them here. And so we need to add them then. Min U32 max 32. So then what we need to do is we take that, first of all we take our angle, we multiply that with the difference between the two, max minus min, and then we need to normalize that basically to 180, and we add the min. So that should pretty much do that little calculation, if I'm not mistaken. So this part we just add here the interpolate, and it needs some more parameters, angle min max. Okay, and then it should set it to that value, and then it drops the lock again. Well, let's see. So let's go back to the add the camera here. First of all, we need to flash it, of course. So we do a cargo ESP flash. It is pretty slow. I have the impression that that's because of my cable, which is kind of long, this cable. So I'll try again with another one, because it's yeah, it takes forever. And I once tried with another cable, it was much quicker, but I lost that one. So I'll need to do that. So I'll fast forward through this a little bit, because it is not super exciting. So nearly done, but before we go, I would like to point out some things about the wiring. So first of all, the servos typically have like the 3 wires. There are 2 kind of color schemes. In this case they are yellow, red and brown. In some cases the brown is black. So the black is basically the minus, the red is the plus, and the yellow is the signal cable. So what I did here, there's like a sort of a connector, which is a pretty common one in like RC planes and cars. I connected the signal wire to pin 2. I connected the plus to the 5 volts of the ESP32, and I put the black one to the ground. If for really small servers you can get away with that, just powering it through the ESP32, and so by your USB basically. If you want to have big strong servos, then they need their own power supply, because otherwise stuff happens. But let's have a look here. This flashing seemed to have succeeded, so it says that it has another endpoint. So that is good. Let's go to our Thunder client, and there I already made one before. So this is the endpoint we made. As you can see, usually right here you see this is the IP it got. It always gets the same one. That makes it a bit easier. Slash servo, a post again, and then we can add a number here in the body, and if I post that, that should do something to the server. So now I say it's 90, and then let's see if I send it, it moves. And then I go back to 0, and it moved back, go to 180, all the way, and I can make small changes, like to 170 maybe. So that's it. It's pretty nice. I try to keep it all pretty minimal, but it's a nice toy, I think, and I think for software people like me, doing something that actually moves is cool. And now we can use quite nice languages like Rust to do it, and without having too much embedded boilerplate, because in my opinion, software developers have a little bit less of a tolerance to difficult tool chains, and I think the ESP32 toolchain for Rust is getting pretty good. So thanks to the community for that, and I'll see you next time.